My name is Stuart Russell, and I'll be moderating this panel, which is on the future of human-computer interaction. And just to reintroduce our panel members, we have Guru Banavar, who is responsible for beating Watson at IBM, the next generation Watson systems. We have Sherry Turkle from MIT, who's an expert on the relationship between people and technology. We have Cynthia Breazeal from MIT, who is a social roboticist and also an entrepreneur, the founder of the Jibo company. And we have Barbara Grosz from Harvard, who works in the natural language area, is a pioneer on the topic of dialogue and on cooperation between humans and machines. So let me open the panel by saying that we're all very familiar with the interfaces that we have now with our laptops, with our smartphones, and they seem fairly seamless, except sometimes they're very irritating when they don't quite work right. You might be interested to know that that kind of interface was described in a fair amount of detail in 1909 by E.M. Forster in a story called The Machine Stops. He described something that seems very much like an iPad with video chat capabilities, climate control buttons, and all sorts of stuff like that. So what we're going to talk about today is what comes next and how will our relationship with machines change as they become more and more intelligent. So I want to begin by asking Cynthia to talk about what's going on now and where is the trend? Where is the technology of human-computer interface going?
Sure. So I thought I would just start to highlight the diversity of embodiments of computation that's happening right now. So more from the commercial landscape, what we're seeing right now is a whole ecosystem developing around hardware, which makes it much more rapid and iterative to be able to create hardware of different kinds of embodiments. And this is also related to advancements in 3D printing and so forth. So whereas many of us are familiar with kind of the traditional boxy, type at it, swipe at it sort of interaction with computers, we're starting to have this whole internet of things and wearables where the computation is becoming more physically intimate. So whether it's the Apple Watch or Apple Watches or Google Glass, we're starting to see these kinds of interfaces. VR headsets and so forth are coming up that literally try to trick the brain by beaming, light signals into your eye to make it feel like you're that much more immersed in the experience. We have robots, of course, that are articulate and able to move around and interact with us, sometimes in a social way, sometimes in another more tool-like way. We're starting to see, of course, there's prosthetics, right? When we think about leg prosthetics or arm prosthetics, robots that are becoming more of an extension of ourselves, that's another form of computation. And as we think into the future, we're starting to move into a more intimate fusing of biology with hardware, so things like neural brain-machine interface, neural implants. We're starting to see artificial retina. We are all familiar with cochlear implants that allow blind people to start to see again or deaf people to hear again. And I think, when I think about looking ahead, one of the things that's always fascinated me about biological systems that we can't do in our silicon-based technology yet is that biological systems can heal and they can grow, and our silicon technology can't do that. So I can imagine, and I think there's work going on at MIT and other places, we're starting to treat biological materials as an engineering material itself. So can you actually design and print out neural structures as an engineering endeavor rather than studying an existing brain or muscles and things like that. So I think there's many directions this is going in and can go in. So you ain't seen nothing yet, to quote the last panel.
So Sherry, when you hear this, does that make your skin crawl a little bit?
No, I think that the way I see it is that what we have to get better at as people, as humans, and we were just chatting about this, we couldn't wait, we've been chatting before we came on, is understanding kind of where our vulnerability is as humans to things that start to make us feel less human in a bad way. So when I hear about a cochlear implant that will enhance the ability to see, to hear, and all the implant, I'm thinking, great. No skin is crawling, it feels to me like an enhancement in all of the best ways. Where I begin to feel I want us to be vigilant is when an interface or a computational object starts to intrude on an area or pretend to be a thing that it really can't do the way people can, and where we will somehow trick ourselves into getting less than we deserve to have. So for example, and this is a conversation that Cynthia and I have had sometime, if you create a computer best friend that comes out of the box, as I think Hello Barbie may, promising, hi, I'm Hello Barbie, I have a sister, I get mad at her, do you have a sister too? To a child who might have a sister and might want to have that conversation, they're hearing pretend empathy from a creature that doesn't have any to give. And I don't think you can learn empathy from a creature that hasn't had that empathic experience. So the question becomes, why make robotic interfaces, in this case, do something that they kind of can't follow up on, can't really deliver on, and that may cause us to forget what the real thing is. So, but other than touching on those kinds of areas where I think we're quite vulnerable, no crawling at all, no.
So you don't worry about us merging our physical brains with electronic augmentation. For example, prosthetic memory might be a possibility, that we could augment our short-term memory so that we would have significantly greater cognitive capacities than we currently have. Does that worry you?
Well, yes, but in the sense that I think we're going to get better at understanding our vulnerability to why we want to begin to do that for medical reasons. See, I think a lot of these technologies are going to be developed for medical reasons. People who have Parkinson's, people who, the technology for working on memory and computation is going to be developed because of medical issues. So I don't think this is a technology where you're going to stop the research, or should you? And then I think we're going to have to get better at figuring out, well, what are the places where we don't want to use it? But this is coming up not just in computation, but in every area of our dealing with the gene, with every area of scientific life. And I think that's where we have to get better, is understanding as people where we, what are the institutions that we need to bring us together, to really as communities, to talk about these issues, and also where we feel that we want to sort of draw the line about parts of our humanity where we think there should be a kind of humanity, or some people don't think there should be a humanity, they should get their airing, and this should be a public policy question.
Barbara?
So I want to support what both Cynthia and Cheryl said. I need a memory device. Cheryl said, and I want to just say a little quip, as it were. The biologists have agreed not to clone humans, and I think AI researchers should agree not to clone humans also. That there are many things that machines and smart machines could do for us. As I said in the earlier panel, we know how to make human beings. And I think it's these that we should think about. I absolutely agree. We should not, the science must continue. Scientific inquiry is important. It's back to Guru's very quotable quote of, what's the danger of not knowing? Then the question is how we're going to use these. And I would like, at some point for this panel, to turn its attention not just to how we as individuals are going to use these, but really to the use of computing in the large. And it's not just social networks. It's groups of people working together and working together with machines. And what is the proper role of people and of the machines? And how do we design these machines, as I said earlier, to make us smarter, not dumber, to complement what we do. And I think that's it's a design and an ethical challenge for us to think about what we want the machines to do. So I personally think it's hard to predict where the hardware will go. I think if you read science fiction, that's one of the things that is often not quite right, or they have way underestimated where we are. It's this other issue where we're talking about what we would like them to do.
Yeah, I do. Okay.
So I'd like to just step back and think about the objectives for good user interface design here, right? So it's one of the three very important objectives for what we consider cognitive systems, which is to be natural in the interaction with humans. When you have a partner that you're working with, you want that partner to be able to understand your intent, your language, your gestures, all of the above. And you want to be able to understand what your partner is telling you in terms of the information and the evidence and everything else, the interconnections, all of that. And in some cases, you also have to consider, what is the model of the world within which we are operating. You can think of an immersive environment in which both your partner or multiple partners and your collaborators and you are working in. I want to give a couple of concrete examples. You think about a corporate boardroom, which is the kind of environment that I come from, where you have multiple very bright people are trying to solve a complex problem. Or you can think of an operating room, very bright people trying to solve a complex problem, or a classroom, where all of these environments are collaborative and it's immersive, and you want the interactions to be as natural as possible. So all the design for user interfaces, whether it's hardware or software or the systems that we build overall, must ultimately go towards that goal of being natural.
But here's an example, let me just take the classroom, of where you can make mistakes because we are vulnerable in ways that we don't anticipate to our technology. So classrooms have amazing systems to use within classrooms, very seductive systems that keep students involved with the technology during a classroom. And it turns out that in my studies of classrooms where these systems are used, the technology becomes so engrossing that it can be very hard for them to interact with the professor, with not going on to other parts of the network to shop or to just check their Facebook. And so you have students who theoretically have a great system designed to enhance the classroom, a professor who feels frustrated because the students don't want to be called on because they're so involved with their tools, and students who have kind of lost the gist and who will admit that because they know they're on Facebook, they're shopping, they're texting, they're buying Ann Taylor shoes, they're doing a bunch of stuff instead of being involved with the class.
I would consider those kinds of systems to be not adequate in terms of their cognitive immersion.
Exactly.
Because if it is a well-designed system for a given task, they would actually immerse the students to do the thing that the environment requires them to do.
Exactly, but it means that the environment, the way we often think about environments, this is what we're talking about vulnerability, doesn't take into account the true environment, which is the classroom as a whole, and not just kind of the student in the machine. And I think that's really where I'm kind of with that we have to make sure that when we talk about the environment and everything that's involved with computation, it really is our whole body, our whole social world, our whole psychology, all of the relationships we're trying to maximize in our life, and not just what is the interface between us and the machine. And I think that's where we stumble, is when we think of computer-human interaction, we somehow allow ourselves to think about computer, human, okay, there's the two of us there, we've got it covered. When in fact, it's the whole wide world we're in.
So that's why I really wanted to get us away from just one person and one machine.
Yeah.
But I also have a quick reply to this. I banned laptops in my classroom for just that reason. And I have had any number of guest lecturers come and say to me, it's amazing how engaged your students are.
Yeah.
And the students themselves realize that the minute they get a little bored. So this is why I think it's both a design and a policy issue. The minute they get a little bored, they're going to go off and do something else if that capability is there. So it is a very tricky design and boundaries issue.
I see in the audience some blue glows on faces, so we know who you are.
So I'd like to just to make the point when we speak about teamwork between people and machines. I think historically there's been this conflation of, in order for it to be natural or intuitive, it needs to be human-like.
Yeah.
And I think, to speak to Barbara's point, and certainly my own work, I think what we're finding is that fascinating design space is actually, they're not human, they're never going to be human, but they can complement us in really intriguing ways. And the magic is celebrating the difference and how they can help us to be more effective than we would if we were just people or just computers, right? So I think that's the real opportunity. And I absolutely agree with Sherry. You need to think about the whole context that you're designing to support, because you certainly don't want it to be distracting or to mitigate, the learning outcomes, say, in the classroom that you're hoping to achieve. So just to say again, we as human beings, we work with non-human entities, like, people, might be working with, police dogs as fire, as policemen and so forth. So we understand this concept. You don't have to be working only with human teammates. And I think robots and other technologies are intriguing to think about. They bring their own capabilities, and I think people actually can think about them as teammates in a way that doesn't confuse them with trying to be exactly like humans in that process.
Yeah, I also think one really important thing for those of us designing intelligent systems is to be mindful of the adaptability of people, and that actually we should be building machines to adapt to us. And one of my current hobby horses, as it were, is that the electronic medical record systems have not been designed for the people who are using them. They've been designed for a billing department. And so we're imposing on people to behave in a different way from the way that would allow them to deliver the best care that they could deliver. And I'm sure everybody here has had an experience with some human-computer interaction system where they have to change their way of thinking and being because of the way the system is acting. So I think a major goal as we look to the future is to really enable people to use their cognition in the best possible way, rather than to force them to adapt to a machine because we know how to build that machine that way.
So let me ask the whole panel if you can describe your vision of an ideal future system that is facilitating collaboration among multiple people and multiple machines. What sort of scenario do you see that working well in, and how would it be like to be in it?
I can start.
Sure.
So it turns out we've actually implemented one or two such scenarios today, and I can just describe one of them. If you are trying to make a really complex decision as a group, and I come from the corporate world, so I can use a complex example like if you're trying to acquire a company, which is a very difficult decision because there's so many parameters that you have to worry about. There's a huge amount of information that you need to do research on, and typically this is going to have to happen within a few hours, maybe a couple days, and there's a lot of perspectives that somebody has to bring in. It's a financial perspective, there's a business strategy perspective, channels perspective, legal perspective, et cetera, and of course the ultimately there is a an instinct about what's the right thing to do kind of perspective, which is a value judgment that somebody has to make. So when you imagine all of these people with different points of view and different expertise come together and ask a collaborator, which happens to be a machine, all of the questions that are in your mind. Compare what is happening today to what we can have in the future. Today, a corporate boardroom would have a PowerPoint projector. Somebody comes in with a bunch of slides, and somebody asks the question, can we do this or not? And somebody, another person says, let me come back to you tomorrow with the research done with another set of slides. But that's, really poor. If you had a real-time system that could answer questions as well as project the right kinds of parameters for you to consider, that's the kind of system we already have working. Is it ideal? Probably not yet, but there's a lot of gesture recognition, visual recognition, speech recognition, dynamics recognition between, who is dominating a conversation, whether there are biases happening that needs to be neutralized, what are the objective pieces of evidence that needs to be brought to the table. All of those kinds of features can be done by computer systems, and it's already implemented in some of our running examples today.
I would answer the question by saying that I think the first thing that needs to happen is for people to recognize the power and the efficiency of the system we have now, which is conversation for accomplishing, human-to-human conversation, for accomplishing so many of our interpersonal goals, and of really understanding the work it does so that when we enhance it through adding computation to it, we have a very high standard for the computation we add to it. So, for example, when somebody says, oh, I know what we should do to this conversation, we should add a kind of medical record where you won't be able to look at your patient during an interview with a patient. We'll say as physicians, nuh-uh, that's not real. You know, the work that conversation does in that medical encounter is too important to just add something that primitive. Let's hold off on that. And I think that we've rushed in to adding computation in a lot of places before we sort of allowed ourselves to really understand the power of face-to-face conversations in some of our most crucial human encounters with our children, with our colleagues, with our partners, with our intimates, with our physicians. So I think that a more profound understanding, for example, in the medical context, means that the next generation of collaborative computational partners in medical encounters really will be ones in which there is a computational partner that's adding to the conversation, not systematically detracting from it, because literally your physician is facing a screen, not facing you as you speak. And similarly, just to finish up, in the context that I study most, which is somebody holding a phone and somehow involving themselves with a child, I think we're going to have industry and individuals working together, and almost a kind of consumer movement turning to industry and saying, you know, how can we design these seductive, fantastic objects that in a way that lets us do our work on them, involve ourselves with them, but somehow then release us, make it easier for us to release us to be in the kinds of conversations we need to be in with each other.
Yeah, no, we've all been in restaurants where we see couples who are just talking to their cell phones and not to each other, and you wonder why they bother to go to dinner if they're just going to be on there.
I think that we're going to begin to take the measure of the cost of our having been so vulnerable, and I don't think that we're going to see that. And I don't think that's going to persist, because I think we're going to take the measure of its cost.
Okay, so
can I just?
Yeah.
Sure, go ahead.
I just want to pick up on this because I've recently been doing some work with physicians, and so I'll give you two examples, Stuart. One is that if you have a patient who requires multiple doctors, they need to know what each other is doing, but not everything. So there's a huge, people talk about care coordination, but you can't ask 15 doctors to each know everything that everybody else is doing. It's a cognitive problem for people. We understand from our work on collaboration that there are certain crucial pieces of information that need to go back and forth. So exactly to the point that Sherry made, if instead of having this screen in front, what you have is a system that recognizes that a piece of information that one doctor gathered is now relevant to the encounter another doctor is having and provides that information, that would be a way of augmenting, goes back to Doug Engelbart, augmenting the human intellect, understanding that we can't see everything in this medical record, but there's something that's important to convey. So that's one thing. Another piece that's interactive from the other side is that we know one issue with patients seeing physicians is that they're afraid to ask their physicians questions. And I will say even people with PhDs and law degrees are afraid to ask their doctors questions. But if one could build a kind of assistant to go to the doctor with you when you can't take your best friend, that would remind you wanted to ask something, or give you permission to ask the question, or even just, make a little sound that would signal to the doctor that there's an issue. Again, that would be complementing what we're doing rather than interrupting what we're doing. So those are the kinds of near-term, medium-term collaborations that I'm thinking would be very, very important to do.
Yeah.
whatever the interface would look like.
I'd like to just,
Cynthia,
just
do you-
add.
yeah.
Yeah. So today, when we think about technologies today, so much of it's focused on our cognitive selves, our cognitive minds and information and so forth. But we know human teamwork, it's also profoundly social. There's profound emotive factors. There's even physical attributes. So I think as we design the future technologies, in order to really support the whole person, these systems do need to be more savvy and capable on all of the dimensions of the human experience, but to do it in the right way so that you don't interfere with our ability to engage these competencies. I would call them our signature strengths. On the negative side, they could be vulnerabilities, but they're also our signature strengths as a species to be able to support us to be the most effective. So I think technologies that address deeply our social selves and our emotional selves, in addition to the cognitive and the physical, in the right way, is going to be really important to create technologies that support us to our best ability.
So let me go on from there and ask you whether it's important for machines to at least appear to display emotions in their interactions with human beings. And then after that, if you've seen the movie Her, I'd be interested in your reaction to that particular relationship and how that evolves.
Okay, so I'll answer that, okay? So again, speaking to the point Barbara made, and certainly in a lot of my own work where I develop these social robots, it's a different question as to can you create a machine that has human emotions, which I would say no, because machines aren't human and they're never going to be, versus what does it mean in the context of that artifact in that machine, and what are the attributes of that interaction that can be designed to bring about the best possible outcomes for the person. So it's complicated and it's nuanced. I don't think it's a one or the other, right or wrong. I think there is a design space, there's a continuum there to understand deeply that's fundamentally in service of the person and what the goals the person has. So I don't think it's a simple answer, but I will tell you that in a lot of these technologies, framing them as not trying to be a human like Samantha and Her, which is very much coming across as, I'm just like you, I'm as smart as you. I think there's a huge design space that's so exciting where they don't have to come across, they don't have to try to portray themselves as being human at all. And there's actually an opportunity there, almost speaking to what Barbara was saying about we interact with, say, companion animals differently than we interact with humans, and they provide us with social support in a different kind of way that that gives us value, right? So I think as our technologies and our interactions and relationships with them evolve, I think it'll be different.
With what kind of hands?
With companion animals that provide social support. Companion animals, not human species, different kind of experience, but a different kind of social support because of that. So I think as our technologies evolve, we're going to figure out the nuances of this, but it's exactly like a relationship that already exists, because it's just not going to be that. And I don't think that's an interesting question to ask, is how to make it the same of what we already have.
Since we're supposed to be controversial, I'll try and take an even stronger stance. I have to tell you, I couldn't really watch Her, but I did watch Ex Machina. Okay. So it's the same. It's the same question. I think we should not build machines that try to look like people. I think that our intelligent machines should do their best to make it clear when they're not people, and it's for some of the reasons that Sherry and Cynthia have brought up. I think it's not easy to do that because we do very easily attribute agency to anything that acts like an agent. So I would actually go further. I think one of the challenges, and I'm looking especially at the two of you, is that to have, and going back to Guru's point of having a natural interaction, is that there is a certain level of conveying emotionality, conveying social interaction that's important to have a successful interaction with a person. So how do you do that without misleading the person into thinking that you're human?
Well, I think, I'm sorry, just to say that, actually it was a project of Cynthia's that has always been a model for me about the appropriate fluidity that you need in terms of body and economy of gesture and sort of knowingness that a robot should have in its embodiment. That has always been a model of kind of appropriate robot empathic behavior. And that's the astronaut assistant. I mean, there you are in space, and you're fixing something out there in space, and typing a message to your robot assistant is clearly not the way it's going to happen most effectively, but going, is the way that's the way, is the way you're going to express urgency, because that's what you're going to be doing, and you certainly want your robot to understand that that means I'm in trouble, as opposed to, trouble or SOS or something. So we know that with enormous economy of gesture, we know how I would know to express if I wasn't feeling well out here. And I know that, 4 people would come to my help. That's what you want from your robot. Now, it seems to me that's appropriate where a robot, and this is why I say that I think we need to use our smarts as people to come up with this, and we can. A robot that pretends to understand something about death, dying, loss, sisters, jealousy. These are areas in which a robot friend, a robot companion, the kinds of robots that certainly her comes right out and says, I know all about love. Here I go, I'm for you. These robots, to me, feel as though they're touching on something they don't know and only demeaning what we do in a way that a cat doesn't, because it has its own kind of connection and is proud to show it off. Excuse me,
I was going to add that whether it's embodied or disembodied, right?
Yeah.
These cognitive systems, as we think about it, should have a model of, not just of the world, but specifically of you or a bunch of collaborators, partners, and of itself, in order to have a better understanding of what the goal of the interactions are. And so to that extent, I think it's important to have at least some information about what state one of the collaborators is in, or all of the collaborators are in, so it can guide in the right way. So there's this model of the world. I think in the extreme, in AI we think about it as theory of mind, which I think is a very far out goal. But I think even in the small, in the short term, you can have state of mind as an important element of the interaction.
So we know from studying dialogue, which as Stuart mentioned, I did a long time ago, that you can't in fact carry on a dialogue with someone unless you have a model of their mental state and can figure out their intentions. We also know that those things are very, very hard to do well in a computing system. And I think those are also important goals as we look forward. And I will say, it's hard enough to have a system that can model one person, but I'll try one more time. What about all of these social networks? What about all of the connectivity we have now? So we started with Cynthia talking about the new materials and what difference they'll make. But there's a whole different level of human-computer interaction going on now, or a whole different level of human interaction going on now using computers. And one might ask, could computers play an important role in things like the running of cities? This is something that I'm chairing this AI 100, a 100-year study of AI that's at Stanford, that's going to take the pulse of AI every 5 years, over 100 years. One can imagine many wonderful uses of smart systems in supporting people in much larger groups getting things accomplished. And what does the interaction style look there? How do we complement human cognition in that sense?
To follow on with that, so in thinking about the future of intelligence, we often think of it in terms of one human mind, one human brain. That's kind of what we need to understand. But in our opening remarks to the Nobel Prize, the Nobel Week, it's very clear that we face so many of these global challenges. We live in this world that's intimately connected. Our actions down now at the level of individuals have impact, right? And so the one thing that we as humans are still not good at is, call it global intelligence. How can we, as a planet, as a people all over the planet, make decisions, learn, adapt, perform actions for the global good? We're not good at that. And with climate change and all these things, we're facing the point where either through our action or our inaction, it's, heading to the abyss, as I think the words were, right? So can technology help us become intelligent at a global scale so that we as a people and a planet can address these huge challenges we face?
So it's a great question. So I wanted to ask one more question before we throw it open to questions from the audience. And there are microphones, so if you have a question, please raise your hand, and someone will bring the mic to you. So the question I wanted to ask is to look further ahead, and if we do have machines that are much more intelligent than us, will they need to hide their intelligence so as not to crush our poor little egos?
I just want to, I will answer that. I will answer that
Stuart,
by
that question is so telling.
I will answer that by answering the question about her, which was that in the end, the intelligence that was developed in her really wanted to hang out with other AIs and really didn't want to hang out with Joaquin Phoenix after she had tidied up, after it had tidied up his book proposal and had has kind of organized his files and his life, and she was ready to. I keep saying she because it was voiced by Scarlett Johansson. It's impossible not to imagine it as a woman, but I mean, she was ready to move on to, to others of her kind. Mm-hmm. And so I think this is our insistence that we're going to create an object whose really main interest will be hanging out with us, I think is also part of a kind of a very old-fashioned fantasy. I think Barbara's trying to get us moved away from this, is, let's think about, creating artificial intelligence that will enhance our life and stop thinking them as our kind of best friends.
Yeah, I think
there are other models.
There's a premise in what you said, Stuart, which is that they will be smarter than us, but I think they will be differently smart from us, right. And that's what we should aim for.
Yeah, I would add that it's, again, come back to the goal of enhancing our life, helping us with our goals and intentions. So if hiding or showing is the right thing to do in order to do that, that's the world model that the AI system should adopt.
So you're saying, yes, they should hide their intellects from us.
Whatever it takes to be the right partner, is my view.
Okay. So on that note, I'd like to open it up to questions from the audience. So if you have a question, please raise your hand, and there should be 3 microphones in circulation, although it's very hard for me to see from here if anyone has a question.
There's one up there, I think.
Okay, down the front.
Hello, everyone. I had a question which was a bit more short-term in scale. Everyone nowadays basically interacts with machines with 3 operating systems, Microsoft, Mac, or Linux. I was wondering, why do you think after 20 years there's still only 3 operating systems, 3 companies making them? Is this good or bad? I think we all know it's bad. And how can we change it?
I think it's amazing that it's your contention is that there should be more, or it should have narrowed down to the best.
I think that you can't. There's 7 billion people. I don't think you can have one best system.
Right. So you're wondering why there aren't so many.
Why don't I have my own personal operating system? Yeah.
So
why do I have to use Windows 8?
So
I think the answer to this question has so much more to do with markets and business models and dynamics that are well beyond the scope of technology and even society, I think, right? But at the end of the day, there are so many new ideas floating around in the entrepreneurial ecosystem. I look at dozens of different great ideas, and which one will catch on and which one will succeed is a much bigger question than, than what the technologies are good for and what people think about them today. But I definitely would say that many new elements, even if those companies don't succeed, many new ideas from those companies will make their way into our lives.
So I have a flip answer and a serious answer. The flip answer is the architecture of one brain seems to have done the human race pretty well. Now, those operating systems, obviously, none of them is quite as well architected. So that's my flip answer to the, we should maybe only have one, but we don't know what the right one is. So we better try a multiplicity, as we do in research. I think that the second issue, the second more serious answer is really related to what Guru said, which is that there are these systems out there. There's a lot invested in what's recorded in those systems and what they're used for, and getting the industry to move and users to move, that is, people who are users to move, is a rather difficult industry question and challenge.
Okay, another
so
question.
Could I ask if people who ask questions could at least give us an idea of whether they're students or not students, or
who they are? Yeah,
who they are? Yes,
that would be nice. Okay, we have one up about halfway up on the right.
There's
Hello.
somebody standing over there.
Hi,
Okay.
I'm a student at Chalmers University of Technology. While it is important for machines not to mimic human emotion, would you say that if we were to flip it, is it important for them to, or would it be beneficial if they recognized human emotions and adapted the approach and tone in accordance to what the human they're interacting with is feeling?
Absolutely. I think it, we talked about this a little bit before. I think there's got to be a recognition of the intention and the state of a person. It's very different when a computer, let's say a personal assistant like Siri, talks to you about, some question you asked about, let's say, calling somebody or whatever, and not finding that person to call might have a very, different way of articulating to you why the computer did not find the person. If the computer knew what were the actions that you did before, maybe it was because the person is not in your network, maybe they're not a friend, whatever it is, right? So it's very important for the computer to be able to articulate answers to your questions in the context in which it is most natural to you.
I just want to
have a follow-up just quickly. But don't you think it's important for the machine to have some perception of emotion when replying as well? So, I don't know, does that affect interaction in some way?
I'm sorry, what is the point about the machine?
If the machine replies in a way that a person interprets as insensitive, would that have some effect?
Yeah, I agree with you that it's important for the machine to understand whether to answer in a maybe a curt way or a nice way, right? And yes, machines are very bad at it today, and that's why we get frustrated with machines all the time. And so we need to improve, and we need to not only research but also develop a lot of these technologies that understands the state of mind.
But also, I mean, and maybe Cynthia and I will disagree on this, and it could be of interest. I think that if our expectation was that the machine wasn't trying to be a person, and I think this is a theme that's come up, but the machine was trying to be a gracious machine, but not trying to be a person, but a gracious machine, a machine that interacted well with people, but not a person. It would have a diction and a way of addressing us where we would be less vulnerable to being hurt and wouldn't have expectations of its. We wouldn't substitute what you're very delicately calling expectations of user state with empathy and expectations that it understands things that it couldn't possibly understand, and where really we could get into kind of emotional trouble if it did. Yeah. And I think that's the research and design area where I think Cynthia and I are sort of talking about, where you can get into trouble or you cannot get into trouble depending on how we play it, I think, over the next little bit of time.
So I think what Cynthia was saying earlier about animals, I mean, animals display emotions, and they're different from ours. Dogs have a variety of emotions that we typically don't display ourselves, but we sort of, at least we think we understand kind of what's in the dog's mind. And that emotional repertoire hasn't been developed yet for machines. I mean, there's one emotional indicator that they have, which is some kind of rotating thing, right? Which basically says, I'm sorry, I haven't a clue and I can't get the answer to your question. I'm just going to go round and round and round and round. Right? As opposed to the stripe, which goes across, which kind of says, I'm getting there, okay, I'm done, right? So there's two different versions of that emotional repertoire, but that's about it, right? There's really nothing else that is sort of widely accepted and understood as a kind of a robot state of mind. But eventually, and it'll depend on the capabilities, there's no point developing an emotional repertoire that the machine's capabilities can't really support. But eventually, I think we will start to see a wider repertoire of emotions. So, confusion, how do you express the fact that the system doesn't understand the input that you're providing to it? Other kinds of things like that will start to emerge in our design.
Yeah, I think they're really, you've asked a question that has two sides. One is, what should the machine be able to detect in the person? And I think the answer is it should be very, very good at understanding us. That's one of the important things. And the other is what it should display to the person. And there it should display in a way that is responsive to what it detects in us, but still makes clear it's a machine. And there are many studies, I think of all the Cliff Nass studies, that show that we respond differently to machines in some ways and similarly in other ways. We have different expectations of machines than of each other. And so it's important to have that right signal.
Right. In the world of natural language processing, though, I just want to say that, when a machine is responding in English, say, there's so many more dimensions of how to display. Something that is maybe better receivable by you, right? And something that's more understandable in the state that you're in. So, once you get into, when I say natural, I mean language is a very important component of it. It's not just, icons, right? And when you use language, there's so many nuances, and that's why it's so complicated. And even then, there's opportunity for being clear that it's a machine, but there's also a lot of challenges in not crossing that line and giving the impression that it actually understands.
So I'd love to continue this conversation, but I'm getting the hook. It's time for us to wrap up. So I'd like to thank the panel and the audience for their questions. And the answer is we ain't seen nothing yet, and it's complicated. Thank you.
Great.
Thank you.